Okay, so today we're going to look at some more word problems that are a little tricky, but again, we're going to read through the word problem, pick out what we know, what we want to know, and then we're going to relate the two. So it says a right triangle. Well, I know what a right triangle looks like. Has a vertex on the graph of y equals 16 minus x squared for x greater than 0. Well, I certainly know what that graph looks like. It's got another at the origin, another at the positive x-axis, and then it's asking me to find the area. Sorry about that. It's asking me to find the area of the triangle. So a couple of these things. I know what this looks like, and I know it's for x greater than 0. So this is a parabola that opens down and is shifted up 16. I know where the origin is. I know where a point x0 is, and I know the formula for the area of a triangle. So let's get a picture of what's happening here. First thing I'm going to do is graph this. So I'm going to go 2, 4, 6, 8, 10, 12, 14, 16. It's shifted up 16. And if I put 0 in here for y, I would get x is plus or minus 4. So I'm going to spread this out a little bit. But I'm only going to graph this part of the parabola right here because it definitely says for x greater than 0. So I'm only the positive half of the parabola. Then it says we've got a right triangle where one vertex is somewhere on here. We're going to call that our random xy point. The other vertex is at the origin, 0, 0, and the other vertex is somewhere on the positive x-axis. But remember, this has to make a right triangle. So wherever this point is, that point, that third point on the positive x-axis would have to be straight down from it in order to create the right triangle. Now this looks like the point 2, 0. But remember, it's random. I don't know that that is x is 2. That could be over here, and then x would be down here. Or this point xy could be up here. So it's just a random point. So what I want to know is the area of the triangle as a function of x. So let's go ahead and look at the formula for the area of a triangle. Area is 1/2 length times width. So if I look at my triangle, this bottom of the triangle can be the length or the width, it doesn't matter. Now, if this is the point x0, then that length or that width is x. So what I have is 1/2 x. And then if I look at the triangle, the legs of the right triangle make up what you call your base and your height, or your length and your width. And so would we agree that that's y because you go over x up y, so that width is y. But remember, this has to be as a function of x, which means I can't have y in my formula. My formula can only have x in it. That's where the equation of the parabola comes into play. I can take that y and I can plug it right back in there. So I have 1/2 x, and instead of y, I make 16, whoops, hold on a second, 16 minus x squared. And that is the formula for the area as a function of x. Now let's talk about the domain here. Remember, the domain is what x could be. This is x right here. X has to be bigger than 0 because it's the base of the triangle, and the triangle wouldn't exist if the base were 0. And the biggest it could ever go out to, it could be anywhere under this parabola. So the biggest it could go out to would be 4, but not including 4. So the domain becomes very important when we go to the calculator in the next video. Okay, the next problem, I want you to put a star by it because it's super important, and I guarantee you it will come up on some type of test or quiz in the near future. So we need to have a rectangle that's inscribed in a circle of radius 3 inches. Well, I know about circles. We studied circles in Unit 1. I know the equation of a circle. Now, your circle could be anywhere on your graph because we're not concerned about the position of the circle as much as we're concerned about the size of the circle. So just center your circle at the origin. It makes the math easier. The equation for a circle centered at the origin of radius 3 is x squared plus y squared equals r squared, but my radius is 3, so x squared plus 9 squared equals, x squared plus y squared equals 9. I know where quadrant 1 is. Quadrant 1 is this quadrant up here. And then I have a point in quadrant 1 that's on the vertex of the rectangle and on the circle. They asked me to express the area of the rectangle. Well, that's something I know. The area is length times width. And it asked me to express the perimeter of the rectangle. Well, that's also something I know. That's 2 lengths plus 2 widths. And what they want is they want area and perimeter, so we're gonna have 2 formulas here, as a function of x. So let's get a picture of our circle. I'm gonna go make this 1, 2, 3, so my circle's not so small. 1, 2, 3. 1, 2, 3. 1, 2, 3. So here's a circle of radius 3. Excuse me. Now we need to inscribe a rectangle in that circle. I'm just going to do it in pencil for a minute to show you that depending on where I inscribe, and inscribe means all the corners of the rectangle are on the circle. So it could be there, it could be here. As you can see, depending on where I inscribe that rectangle, I get a circle of a different shape or size, a different shape and size, which means they have different areas and different perimeters. And what we're doing is we're just looking for the general formula for area or perimeter. So I'm gonna put my circle right here, my rectangle right here. Okay, something like this. Every corner of the rectangle is on the circle. And what it says is you have that random point xy, just like we had the random point xy up above on the parabola. We have a random point xy that's on the circle, but it's also a vertex of the rectangle, and it's in quadrant 1. It's this point right here. That's the point that's on the vertex of the rectangle. It's on the circle, and it's in quadrant 1. So now we need to figure out a formula for the area. So we know that area is length times width. But it needs to be in terms of x and y, and then eventually just in terms of x. So if I look at this, let's call this our length of our rectangle. It doesn't matter which is your length and which is your width. Okay, that's the length of the rectangle. That rectangle, that length is x. Because from here to here is x, because if you were to graph this point, you'd go over x, up y, which means this distance over here is also x, making that length 2x. Using that same logic, from here to here is y, which means this is also y, making my width 2y, so that's 4xy. Okay, but now remember, this needs to be as a function of x, which means I can't have this y in. Now, if you remember up above, we plugged the parabola in for our y value. We got to do the same thing with the circle. The only difference is that the circle is not solved for y. So I'm not ready to plug it in. So I have x squared plus y squared equals 9. So subtracting the x squared from both sides, I'd get that. I'd square root both sides, so I get plus or minus this. And now you have to decide, is it plus or is it minus? And this is why they had to tell you that it was in quadrant 1. If the point xy is in quadrant 1, the x's and the y's are both positive, meaning I'm only going to look at the positive 9 minus x squared, not the negative, because my point is in quadrant 1. So now I can replace that into there. So I have area equals 4x, and in place of the y, I'm going to put square root of 9 minus x squared. And that is a general formula for the area of any rectangle dependent on the position that you put x in. And then we have to do perimeter, and it's the same thing. Perimeter is 2 lengths plus 2 widths. Well, we decided the length was 2x and the width was 2y, so that's 4x plus 4y. And then once again, it needs to be as a function of x, which means I can't have this y. So I need to take that y formula and plug it back in. So it's 4x plus 4 times the square root of 9 minus x squared. And that is a formula for your perimeter.